In this video, we're going to walk through the process of deploying a set of Telegraf agents to a set of target nodes. And we're going to target them based on the application. So we'll deploy Telegraf agents to our Kafka nodes in this example, and configure those Telegraf agents so that they report the logs and metrics information that they gather from those target nodes to a Kafka cluster. Specifically, the metrics will be reported to the metrics topic, and the log information that's gathered will be reported to the log topic, or the logs topic. So in the end, we'll have Telegraf agents deployed. They'll be picking up metrics and logs information and reporting that information through to the Kafka cluster. And then the Kafka cluster already has, as we showed in the previous video, a connector running in it that'll pick up information from the topics that I mentioned, the logs and metrics topics, and forward that on to an associated S3 bucket on AWS. So let's get started. The first thing to do is to go through the files that are used for this process. As is the case with most of our playbooks, or nearly all of them, or maybe all of them, there is a Telegraf variables file, an application variables file here. As you can see, the application by default is set to Telegraf. This is the target node tag, so it's going to look for the Telegraf host group and target that host group. And specifically in a cloud environment, it's going to look for nodes that are tagged with the application Telegraf plus all the other tags that might be in the config file. So what we're going to do is we're going to have to change this to reflect the application that we would like to target. And the thought here is that the logs and metrics you might gather would vary from one application to another. So we're going to go ahead and make our deployments per application. Again, in the custom config file we're going to build shortly, we'll change this to the Kafka application as our target. In addition, there's this configuration list, and this actually creates the configuration not only of the measurements that we want to gather, the measurement sets in this example, but also the agent. So this is going to customize the agent to set the precision of the timestamps that it associates with the data that it gathers to be to the nearest nanosecond. In addition, we create two measurement sets. A measurement set has a name, which should be unique, an input filter, and an output filter. For the metrics measurement set, our input filter is a standard string that's defined colon separated set of values that we want this agent to gather that are metrics. And then we send the CPU, disk I/O, etc. information that's gathered by the agent off through this output filter of Kafka. And the config for the Kafka output filter is right here. We want to report that through to the metrics topic, and we want our JSON timestamp units for the data that's reported to Kafka to be the nearest nanosecond. So we won't lose any precision over the timestamp precision with which these metrics were gathered. The second measurement set we've named log parser. Name doesn't really matter, but I've set the name here to reflect the same name as the input filter. It's using the log parser input filter. And again, we're sending our output to Kafka. The config in this case for the Kafka output filter is that we want to send the log information to the logs topic. Again, with a timestamp unit for our JSON messages of the nearest nanosecond. And for log parser output filter, or input filter rather, we have a similar pair of configuration parameters. By default, it looks in the var log directory, and it looks in any subdirectory under var log for any file that ends in .log. You can change this to a fixed list. You can add additional subdirectories with additional patterns. This log paths is the list of paths over which the log parser will look for log information. And when it finds a log in this log path, it goes ahead and uses this pattern to parse that log and convert it to a JSON timestamp, or a JSON message. Convert it to a piece of data that we will place in Kafka as a JSON message. So this custom syslog pattern You probably won't have to change if you're parsing syslog information. If you're parsing logs that have a different format, you'll have to identify the right pattern to use. And this is a list of patterns where each pattern is a name and value. The patterns themselves can be found in the log parser input filter description, the documentation for that, at the main Telegraf project website on github.com. Of course, we need to know how to talk to Kafka, so we have to set the plain text and SSL ports. These need to be set the same as the values that were used when configuring the Kafka cluster that you're reporting your metadata to. There's a flag here that indicates whether or not we should secure the connection with the Kafka cluster, and of course a private key path, just like in all of our other playbooks. The default configuration file is very simple and basic. There's really not much to it, and for anyone who's walked through any of our videos previous to this one, this should be pretty easy to see. So the first thing we're going to want to do in order to run our playbook is we're going to want to go ahead and create our custom config file. As I've shown you in several of these, I'm going to go ahead and duplicate this, rename it config telegraf.yaml. And then I'm going to add a few lines that I'm going to copy and paste from another window. The first couple here are the private key path, which I'm going to set to the temp key files directory, just like I have in the previous videos. And as I said earlier, I'm going to change my application to Kafka so that we'll find our nodes. Now, we got to match our other tags, so the data flow has to be set to pipeline, and the cluster needs to be set to A. So now we should be able to find that Kafka cluster that we already have running. The other change I'm going to make here is I'm going to change the configuration list just a little bit, and I'll go through the change momentarily. Again, I'm just going to copy and paste this from another window. The agent and the first measurement set are identical to the default configuration list, but in this third measurement set, the log parser measurement set, I've added this additional line here to the log parser configuration. And this just tells the log parser that it should start parsing the logs from the beginning of the log file rather than starting to parse the logs from the end. By default, the agent would start up and only pick up changes in the logs that were reported after the agent started. This will actually start parsing from the beginning. So we should see more log output in the process. So we've got our custom configuration file built. Let's go ahead and provision our Telegraf agents. So again, just to review, we're using the provision Telegraf playbook. We're using the custom configuration file we just built, and our standard AWS profile that we've been using for all of these demos. This is going to go out and find a list of the nodes that match our Kafka host group, and then it's going to use that Kafka host group as the target, and also use it to determine which hosts or which cluster it should be reporting to. You can see we're installing the Telegraf agent on those target nodes. We go through a little bit of customization of the agent configuration here. Specifically, we set up the precision properly, and then we disable a bunch of standard inputs and outputs that the Telegraf agent creates by default. For some reason, it likes to create all of these inputs and outputs for you. They think they're being helpful. I've got a different way I'm configuring this. I'm actually going to configure the inputs and outputs separately in the etc telegraf.d subdirectory. And that's what we're doing here. We're creating those new Telegraf configuration files for each of the measurement sets, and then we're going to go customize those based on the configurations that were passed in for the inputs and outputs in each of those measurement sets. And so when this is all said and done, we will have a default telegraf.conf file with just the agent configuration in it, and then we'll have separate configuration files in the etc telegraf.d subdirectory that have configuration files for each of the measurement sets that our agent is gathering. And you can see as we go through here that it's setting topics and destinations for the Kafka inputs and outputs. It's setting precisions that should be used. It's setting the JSON timestamp units. There's just a lot of information that's being pushed through on as we're going through this playbook run. And at the tail end here, we're going to go ahead and set up our Telegraf service and start the agent, and then enable that agent or that service on boot at the tail end of the playbook run. So now we have our Telegraf agents running. If I come in here and I do a system CTL status Telegraf, you can see the Telegraf agent is running. It's working over an interval of 10 seconds. This should be pushing logs and metrics data through to the Kafka cluster. So how can we prove that the data is actually ending up where it should be? The easiest way to do it is actually with the Kafka console consumer. And if you look at the help for the Kafka console consumer, you'll see that you can work off of a zookeeper string, or you can work off of a set of bootstrap servers. For the time being, I'm going to go ahead and work off of the zookeeper string. And minus zookeeper. We're going to go ahead and grab this string, and our topic is going to be the metrics topic. And if I wait for a few seconds here, there's our metadata coming in from our Telegraf agents appearing on the metrics topic, and then we can forward this information on however we would like to. We could forward this on to the S3 bucket using that StreamX connector that I showed in the previous demo. We could take this and process it in Spark or Storm and make some decisions based on the metrics that are coming in. You can see that each of these is tagged with the Kafka host. The host name is unique for each of these based on that unique host name that was set up during the deployment process earlier on. And so we can gather this data, do whatever we would like to out of this topic. So you've seen in this demonstration that we went ahead and configured a set of Telegraf agents after deploying them to a set of Kafka nodes, and now we have those Telegraf agents gathering logs and metrics information from the Kafka nodes and reporting them to the Kafka cluster as JSON messages with timestamps to the nearest nanosecond. Hopefully you found this video useful. Thank you very much for your time and your attention.